Hi there, my name's James Lister and welcome to my presentation for the Term 1 Assignment 3 Terminal Application. Project Overview. So I wanted to create a terminal app that would feature a game that would be familiar to those in the programming world. That way I would have the framework for a program that would potentially be useful in a programming or development environment. I chose Planning Poker or Scrum Poker as it fulfilled this requirement. To make it more interesting, I based it around the zombie apocalypse. And the project duration was for 2 weeks, December 5 to December 18 or thereabouts. So the main purpose of building this terminal app was to gain a better understanding of the inner workings and processes of operating systems and hardware devices. Terminal applications can be a standard in information technology practices rather than a graphical user interface. Therefore, developing one should increase technical sophistication in not just back-end coding but ability to use other terminal apps. My main goal was to become coherent in dry Python programming language and increase aptitude in all manner of applying Python fundamentals into a real working program. A program that would accept user input and run printed outputs, would utilize variables and correctly assign them values, use conditional control flow structures and loops, import modules including external packages, and read and write file handling as well as error handling. My role as the Python developer would be planning and implementation, test-driven development, coding, testing and debugging, error handling, and deployment. So the next section we're going to take a look at is the planning and implementation, which basically demonstrates my use of project management software, but I'm just going to burn through it to keep the presentation time down. But it includes ideation, definition of application features, implementation plan, breakdown of implementation plan, and execution of implementation plan. So as I mentioned in the overview, I wanted to create something that might be recognizable in the programming or development world. And that's how I came up with the ZAP or Zombie Apocalypse Planning Poker. So the list of program features would include a game intro, a game menu, multiplayer mode, single player mode, high score, and bonus content. I created my implementation plan on Trello's project management platform. You can visit my Trello board by following the link you can see below. The main considerations within my plan were to attempt a TDD approach, design planning poker game first, as it would lay out the initial framework for the rest of the game, and to initialize classes for the player and challenge objects to essentially make the number of players and number of challenges scalable. So the breakdown of my implementation plan went in this order, utilizing the development checklists there within. Multiplayer mode first, followed by the single player mode, high scores, then rules feature, bonus content, and finally the game menu and intro sequence. As expected, the execution of the plan did evolve somewhat over the course of the project, but overall was extremely helpful in order to organize my processes so that I could complete the task within the given time frame. Once I got the hang of Trello, it became an instrumental part of the planning process and a crucial method to track my progress. Learning about Trello was an unexpected benefit from the project overall, and I hope to use this project management feature in the future. The next section we'll take a look at is the overview of the terminal application itself. We've already discussed lists of features, so you'd be familiar with them by now, but we'll take a look at the overall structure, the overall logic and control flow, and I'll give you a demonstration of the app. So just to outline the structure of the app, we're looking at the intro sequence, which uses some styling from external package colored and some ASCII art just for fun, running into the game menu function, which features external package art to run the ZAP ASCII text. The game menu runs on a while loop that waits for user input based off the prompts defined within. The multiplayer and single player mode run off a lot of the same functions, however single player mode executes a few extra functions of which I'll go into in more depth in a minute. The single player and multiplayer mode run in a nested for loop which determines the round based on the which challenge and number of players functions, ultimately running conditional statements to check if cards thrown match or do not match. This in turn runs the player turn or random player turn functions, which are while loops. All of the functions are dependent on the function's number of players and which challenge, which are functions that encapsulate lists of class objects. This was implemented in order to make the number of players and challenges scalable, but also became integral when fetching values and scores of the challenges to compare them against card values or determine the score the players would get from succeeding in a challenge. The more in-depth functions of single player mode are from random player turn while loop. We run throw card function which allows the computer to throw a random card based on a few nested nested conditionals. Once we've thrown the first set of cards that don't match, we run a couple of functions through runNext, which is to check for duplicates, card sorter, and if there are any duplicates, duplicate card sorter. Finally, if the players have accumulated a score, the player mode will run the enter the high score function that performs some read-write file handling. So the rest is pretty straightforward. We've got the open rules function, which is some basic read-only file handling that includes some error handling, and we've got open high scores function that does the same but also arranges the scores from highest to lowest. Last but not least, we have bonus content try except function that I created to demonstrate an understanding of error handling. The input requires a number, but if you enter a string, the program handles the error with a hidden feature, which also includes some file handling. Okay, so now let's take a look at the app. On the executable, zap.sh, a little intro sequence. Okay, first we'll take a look at rules, some file handling there. And next, high scores, same deal there. And okay, so multiplayer mode. This mode is for multiple players sitting at the terminal, so relies on human inputs and therefore human intelligence to select cards within the range of previous cards thrown. So I'm playing each of the player inputs, entering in either ace 2, 3, 5, 8 or king being skip the challenge entirely, with the ultimate goal being to reach consensus. So just enter your name and the program adds your name and score to a high scores list. So next we'll take a look at the single player mode. So this was quite a bit trickier to program as the computer needs to be told to throw within the range of cards already thrown. Otherwise it might throw an 8 when the previous range is between 3 and 5, say, which would be dumb. So the way I solved this problem was to create a card sorter that determines the new range, which was challenging because of the ace and the possibility of duplicates. So everything needed to be sorted according to key value, and I also had to run a check for duplicates function on top of that. So amazingly, my card sorter worked and I was able to call it from the throw random card function, and now each round, if the players haven't reached consensus, a new range is determined and you can reach consensus with the computer players in no time. So now just once again, enter your name and score, and look at that, it's top score. Alright, so the next part we'll look at is the bonus content. So I wrote my program to basically handle any inputs without returning errors, so I just wanted to show a bit of error handling in the program. So the input requests you enter a string, but it actually requires something else. So instead of crashing the program, it opens this ASCII out. I'll let you figure out what input the program actually requires for a secret message. In the next section, we'll be looking at the overview of the code. That'll include code logic and control flow, the review of the development build process, testing and TDD process, and also the challenges I faced when developing the app. So as we covered a few control flow topics in the overall structure discussion, and to make my diagram a tad less complex, I'm going to focus on the single player mode, which makes up the brunt of the program anyway. The three main components are the for loop in the single player mode, the while loop in player turn and random player turn, and the throw card nested conditionals, which also initiates the run next function conditionals that run check for duplicates and either card sorter or duplicate card sorter. Initializing the player class and challenges class was an early decision, and it proved to be a valuable one, as not only did it allow me to structure my game based on the number of players and number of challenges, it also allowed me to give my objects attributes such as value and score that proved instrumental in comparing the challenge values against the card values and attributing the score for challenges once completed. So just to quickly iterate the code logic and control flow, we've got single player mode for loop, random player turn while loop, random card conditional statements, which define the throw card function, which, if cards have already been played, gets its value from the run next conditional statements, check for duplicates conditional statements, card sorter or duplicate card sorter functions, and finally append remaining card values function. So as I mentioned, I tried to adopt a test-driven development approach to the entire project. Essentially, I developed all my code in a test environment, which not only helped to break down problems into smaller challenges, but turned out to be a really good way to learn all the Python fundamentals through trial and error. So I suppose you could break down my methodology into three types of testing. I utilized assertion testing with PyTest. I performed quite a bit of manual testing, also some testing using print statements, which I found super useful in some of the more challenging parts of the project. My development build process worked out well in that it felt like as I was developing each feature, the previous part of the program was instrumental in the development of the next. Adopting a TDD approach proved very helpful as I was able to develop most of my code in a testing environment. As problems arose, I was consistent in solving them quickly. However, I did get stuck trying to solve the random card to be thrown within the new range issue and went down some pretty wild rabbit holes, but I got there in the end. I learned so much about Python and programming in general that I feel I will be a lot more concise on future projects. By the end of the project, my understanding of the dry fundamentals was cemented even if my code began a little wet. Due to the time constraints, I didn't feel comfortable refactoring all of my code, but I mostly cleaned up all the stray elements and made sure everything was within functions to be called instead of repeating code wherever possible. Impacts and what I learned. The terminal app hopefully showcases my new abilities to firstly write in Python programming language and adhere somewhat to fundamental PEP8 styling, understand Python functionality and code logic by writing concise functions containing nested loops and conditional statements, understand control flow and utilizing the correct methods for the right applications, adhere to a TDD approach and dry coding fundamentals. While developing the terminal app, I learned a ton about Python coding language, its functionality and extent of its capabilities. I learned about objects and the classes that define them, variable functions and data types, conditional statements, break, continue, pass and return statements, while and for loops, etc. I learned about external packages and importing them, as well as organizing my code into functions and modules and importing those also. Error handling, file handling, as well as some bash scripting to write my executable file. And that's it. Thanks so much for taking the time to watch my presentation.